Hi everyone, welcome back to my channel. In this video, you will learn how to solve for the nth term of the geometric sequence. Alright, so to solve for the nth term of the geometric sequence, we're going to use the formula a sub n equals a sub 1 times r raised to n minus 1. Alright, where a sub n here is the nth term of the geometric sequence, and a sub 1 here is the first term of the geometric sequence, and r here is the common ratio, right? So the distinct feature of geometric sequence is the r, or the common ratio. And when we say common ratio, it is actually a non-zero constant number that is being multiplied to the preceding term to come up with the new term, or with the next term rather. All right, so we'll discuss that further when we go to our examples later on. All right, and lastly, our n here is the number of terms. All right, let's have the first example. What is the fifth term of the geometric sequence 3 over 20, 3 over 2, 15, and so on? All right, so we're going to solve for the fifth term, okay, of this sequence. All right, so to solve for the fifth term of the sequence, we're going to use the formula a sub n equals a sub 1 times r raised to n minus 1. All right, so we are given of the a sub 1, which is 3 over 20, but we don't know the r. Okay, we don't know the r, but we have the n, and since we are to solve for the fifth term, this means that our n is also 5. So let us try to solve first for r. Okay, so solving for r. All right, so to solve for r, we can use this formula a sub 2 over a sub 1, and since we're given of the a sub 2 and we're also given of the a sub 1, we simply substitute the given. So a sub 2 is 3 over 2 over 3 over 20, and so this will give us 3 over 2 times 20 over 3. All right, so we can actually cancel this, and 20 divided by 2 is actually 10. So this will give us 20 over 2, or simply 10. So the common ratio of this sequence is 10. Okay, so let's box it. Okay, now that we have the common difference and we are given also of n and the a sub 1, we can now solve for the fifth term of this sequence. So solving for the fifth term. Okay, so we're going to use the formula a sub n equals a sub 1, all right, r n raised to n minus 1. Okay, so our fifth term is a sub 1 is 3 over 20, all right, and our r is 10 raised to, okay, n is 5 minus 1. All right, now we can simplify this. We have 3 over 20 times, okay, times 10 raised to 4, times 10 raised to 4. All right, and 10 raised to 4 is 10,000. So this will give us 3 over 20 times 10,000. Okay, and 10,000 divided by 20, that will give us 500. So this will give us, okay, 3 times 500. And 3 times 500, that will give us 1,500. This is the fifth term of this sequence. Okay, so this is the fifth term of the sequence. Let's have another one. In the geometric sequence 6, 12, 24, 48, so on and so forth, which term is 768? Alright, so if we're going to list down the given, we are given of the a sub 1, which is 6. We are also given of the last term, or the last term, okay, which is 768. And we are also given of the ratio. Ratio is simply a sub 2 over a sub 1, and that will give us 12 divided by 6, which is equal to 2. Now we are to solve for the value of n. Okay, so which term is 768? All right, so to solve for n, we're going to use the formula a sub n equals a sub 1 times r raised to n minus 1. So solving for n. All right, so a sub n equals, okay, let's substitute the given. So our a sub n here is 768 equals, all right, our a sub 1 rather is 6, and our r is 2 raised to n minus 1. All right, now simplifying this, we are going to divide both sides by 6. So 768 divided by 6, and 6 times 2 raised to n minus 1 over 6. Alright, now simplifying this further, 768, that will give 768 divided by 6 will give us 128. 128 equals 2 raised to n minus 1. Alright, now if we're going to express 128 into exponential form, that will give us 2 raised to 7 equals 2 raised to n minus 1. Alright, and since we have the same base now, we can equate the exponents. So this will give us 7 equals n minus 1. And simplifying further, this will give us n equals 7 plus 1, which is equal to 8. So n here is 8. Alright, so let's check if our answer is correct. So let's check. Okay, so let's substitute n to our formula. A sub n equals a sub 1 times r raised to n minus 1. So our a sub n again is 768, and a sub 1 is 6, and r is 2 raised to 8 minus 1. Okay, so 768 equals 6 times 2 raised to 7. And 2 raised to 7 is 128. So 6 times 128 equals 768. And if you have the calculator there, you multiply 6 by 128. Okay, that will give you 700. Okay, 768. Okay, so this indicates that our answer is correct. So this is the 768 is the 8th term of this sequence.